Question number 21. Which of the following is not considered to be a greenhouse gas? So, nitrogen oxide, water vapor, and methane are considered to be greenhouse gases, but oxygen is not a greenhouse gas. So, C is the correct option. Question number 22. A black body at a temperature T has a peak wavelength lambda. What is the peak wavelength when the temperature increases by 33%? So by using Wien displacement law, we have a relation between lambda max and temperature, which is B by T, where B is a constant. So now they are saying that the wavelength, we have to find the wavelength when the temperature increases by 33%. So temperature 33% means approximately one third of this, which becomes 40 by 3. So temperature is now becoming 40 by 3. So if I have to calculate lambda maximum now, that would be constant over 4 by 3 T. So if I just modify this equation, it becomes 3B by 4T. So basically B by T is the actual wind displacement loss is 3/4. So the correct option would be B, 3/4 of lambda, because this equation is basically for lambda max. Question number 23. A particle is executing simple harmonic oscillations with total energy E and amplitude x naught. What is the kinetic energy of the particle when the displacement from the equilibrium position is x naught by 2? So by using our data booklet, we have the total energy, we have the potential energy. So we can have the kinetic energy as half m omega square x naught square minus x square. Now here they are saying that the amplitude is x naught by 2. So I'll just substitute this in the equation. M omega square x naught square as it is. Instead of x, now we have x naught by 2 squared. Simplifying the equation, kinetic energy becomes half m omega square. So this becomes x naught square minus x naught square by 4. So I'll just further solve this equation. I'm just opening up the brackets. So this becomes half m omega square x naught square minus half m omega square x naught by 4 x naught square. So if we see that this actually is the formula for total energy, this is the formula for total energy. So what I'll do, I'll simply it's total, this is total energy and this is total energy. So total energy minus, I can write it as 1/4 of total energy, which becomes 3 by 4 of total energy. So 3 by 4 of total energy, which is C. So basically from data booklet we can get total energy is half m omega square x naught square. So the correct option is C. Question number 24. An interference intensity pattern is obtained in an experiment with 4 slits. What change occurs when the number of slits is increased but the separation and the width of the slit do not change? Only the number of slits is increasing. So basically the width of this central maximum will change because the number of slits are now increasing. So I can say it's A, the width of the primary maxima decreasing. There will be no effect on position or the number of secondary maxima or the intensity of secondary maxima. The only effect will be on the width of the primary maxima. Question number 25. A diffraction grating with 6000 slits is used to resolve two spectral lines. Mean wavelength of the lines is 500 nanometers and the difference in their wavelength is 0.050 nanometers. What is the minimum order at which the diffraction grating can be resolved? So using the resolving formula, we have R is equals to lambda over delta and lambda is equals to m into n. So if I substitute the values, lambda is 500. Both are in nanometers, so I'm not converting them. Delta lambda change in wavelength is 0.050. Number of slits is 6000 and m basically the order we have to find into 6000. Solving this equation, I get m is equals to 500 over 0.050 into 6000. So solving it, I'll get the value of m to be somewhere between 2 and 1. It will be basically more than 1 and less than 2. So because the value of m is more than 1, so it cannot be first order. Yes, it is less than 2, so it can be second order. It can resolve the second order. So the correct option is B. Question number 26. A siren emits sound of wavelength lambda. So let's say this is our siren which is emitting some sound of speed lambda, and when it is at rest the speed of the sound is c, and the siren then moves towards a stationary observer at speed v. Now it is moving at a speed v towards a stationary observer. Let's say our observer is here. It is at rest, so it doesn't have any speed. Speed is 0. What is the wavelength and the speed of the sound received by the observer when this siren is moving with a speed less than the speed of the sound? Okay, let's talk about the speed of the sound heard by the observer first. Now just imagine this siren is giving out some wavelengths. Stationary, this is stationary observer. This observer is not moving towards or away from the siren. So basically the sound which comes out of the siren will reach with the same speed. The speed can't change because the observer is at rest. The observer is not moving. So speed should be c only. It cannot be c or d option, because the speed has to be c because the observer is at rest. Now the wavelength, yes, definitely the wavelength will change. Why? Now let's just imagine that first wavelength is given out by the siren. Now by the time the second wavelength will be given out, this siren will already travel some distance. Distance is speed into time. So speed v into time t. So when the second wavelength will be given out, this much distance is already traveled. That means the new wavelength which is heard by the observer will be lambda minus this particular distance. Now I know that from the wave equation V is equals to f lambda, or I can write it as lambda by t because frequency is 1 by t. So from here I can calculate the value of time as lambda by V. Now I will substitute this value over here. I get lambda dash is equals to lambda minus V. Instead of time I am mentioning lambda by c. It's basically c, c is equals to f lambda, speed of light. So I can write lambda dash is equals to, I can take lambda common, it becomes 1 minus V by C. So lambda 1 minus V by C, that is option B. Option B is the correct option. Question number 27. An isolated point charge Q is located at point X. Two other points Y and Z are such that YZ is actually double of the distance of this. So if I am saying this distance is X, obviously this distance will become double of this. This is 2x. So I'm just considering the distance to be x. Now we know that the electric field strength is given by the equation kq by x square. That is the distance, where x is the distance. We have to calculate the electric field strength at y and electric field strength at z. So at y we have to take from the charge the distance. So at y it will be k q upon the distance is x square over at z k charge is q but the distance is 2x plus x. So we have to take this whole distance. If we are talking about z from the charge the distance is basically x plus 2x, which becomes 3x squared. So if I just solve it out, it becomes 1x square upon 1 by 9x square. So x square cancelled, it becomes 9. So the correct option is D. Question number 28. We have two very long parallel plates x and y with equal and opposite charges. Potentials on each plate is Vx and Vy, where they are saying Vx is more than Vy. That means if potential on x is more, so this plate becomes positive and this plate is negative. A point particle of positive charge q and mass m is there just between. It is just in the midway of the two plates, and it is held at rest. The particles is then released. Which plate will the particle move towards? Now they are saying it's a positive charge, so it obviously positive will get attracted towards the negative plate, that is plate y. So x and a and b cannot be the options. Talking about kinetic energy, we have an equation from our data booklet that work done is basically q delta v. Now let's calculate delta v. Delta v is a change in the potential. Change in the potential for this particular charge, which is midway. So if this is Vy, this is Vx, the difference in the plate's voltage is basically Vx minus Vy, right? But because it is in midway, we'll take half. So it's basically half Vx minus Vy. Substituting it in the formula, work done is basically kinetic energy only. So Q, then half Vx minus Vy. So this 2 I can basically write here. So I can say it's option D. Question number 29. So we have a hollow metallic sphere of radius r which has a positive charge q. P is a point at a distance r by 2, that is the point P is inside the hollow sphere from the center of the sphere. We have to tell the values of electric potential and electric field at the point P which is inside the hollow metallic sphere. So because this is a hollow sphere, so electric field at any point inside will be 0. That means option A and C cannot be the correct options. Now talking about electric potential, because this is a hollow sphere, so the electric potential at any point inside is constant and is equal to the value whatever it is at the surface, that is kq by r. So the correct option is D. Question number 30. We have a satellite of mass small m. It is in orbit around a planet of radius r and mass m. So we have a satellite which is in the orbit around a planet. The total energy of the satellite is given. So if we talk about the total energy is basically the kinetic energy and the sum of potential energy. So this total energy is given G m by 4r. This is for the satellite, and the kinetic and potential energies will be half mv square, and potential energy will be minus gmm by r. So if I see the satellite is revolving around the planet, so we can say the centripetal force is equal to the gravitational force gmm by r square. So r cancels out, so I can write mv square is gmm by r. So r is basically capital R here. So substituting the values, I am keeping this left hand side as it is. Instead of this mv square, I am substituting gmm by r minus gmm by r. So half gmm by r, this becomes, modifying the equation, it becomes minus half gmm by r. So this negative sign cancels out, gmm cancels out. So r, if I see, basically I am getting 1 by 4 r is equals to 1 by 2 r. This is basically for the orbit. This is for the orbit and this is for the planet. That means it is double. So our correct option is C.